I'm Jennifer Davis. I am super excited to be here. This is my first DevOps Days London, although I've been at a few DevOps Days. I'm already super impressed at the inclusion and inclusivity and accessibility that the folks of the organizers have done here. So I just would like to do a little round of applause. If we can say thank you. Organizing conferences is very difficult, and everyone in DevOps Days is doing this as a volunteer. So if you see the folks in purple and black, please reach out to them and say thank you. So I've been in this industry for over 20 years now, and I enjoy sharing what I learn because I really feel like it's critical to build on what we've done rather than keep repeating the same problems over and over again. So one of the ways I share is organizing DevOps Days. I'm the co-author with Rin Daniels of Effective DevOps. And in there we shared the pillars of DevOps and how you can have an effective environment. I would like to share that as of yesterday, actually, Modern System Administration is a book that I'm writing. It is available for early release, which means that you can download from Safari and check out the chapters as I release them. It's very early, so please be kind, but I would love your feedback as well as any stories that you want to share to be included in the book. So today, what I want to talk about is trust. It is the building block of how we have successful relationships inside of our organizations and externally with our customers. And it's something that's intangible. We can't really look at it, see it. You definitely can't buy it. You have to earn it. And so often it's something that we lose at the drop of some incident. So often when personally identifying information is released, fraudulent activity happens with our bank accounts. And so there's a lot of different areas I could go with this trust, but what I'm going to talk about specifically today is about how we can incorporate it into building our applications. When I was talking to some folks yesterday, one of the things that someone pointed out to me was, hey, I see that you're talking about developers, and what about the users? And I'm going to say a word that I don't like here. What about those stupid users doing stupid things? And I want to ask that, yes, this is a place that you, in this environment, especially in open spaces later, this is a space that we can share our experiences, but I would ask that we frame things so not to use the word stupid, bad, wrong, and kind of endeavor to describe things in a different way. Because the problem is, I think we've done such a disservice to all of our users and even ourselves by not thinking about what challenges we're facing and building systems that allow people to do the things that they want and need to do without trying to act like, hey, I'm going to do all of this security for you, and then meanwhile they assume that good intent and things break. So it's really easy to postpone all of the things we need to think about when it comes to security, which is a building block towards creating trust. Architecture and time to market are usually what people are thinking about. Like, I have to be fast, 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 and security is slow. Often the choice of our frameworks, we make them based on how easy it is to code and what that code looks like, rather than thinking, what happens when the hackers show up? How do I actually use this? Security concerns are all around us. It's happening every day. I feel like I'm one of these paranoid folks that is always reading the news and seeing incidents and thinking, you know, what if? You can check out how you've been owned, your personal information being released out into the wild with the Have I Been Pwned site. And these vulnerabilities that happen, it's not just one area. It feels like we're in this arms race, racing, except we don't even realize we're in this race. All the malicious attacks are happening, and they're aggregating all of this information they're getting from different sources. So it's really critical when we start talking about this. We're human. I make mistakes. We're all gonna make mistakes, and it's okay. We have a tendency to put off these big, giant things that we need to think about that are complex because they're hard. If I think about it like climate change, it's gonna affect us all. And yet, when we stop to think, how are we making changes, it's something difficult, so we put it off. Just like perfect availability and perfect uptime are not achievable, perfect security isn't achievable. So what do? It's not a matter of if you're gonna get hacked, it's a matter of when. And so instead of trying to make all of these things be perfect, think about what risks we have. We have risks to the physical infrastructure. It could be via our networks, our compute infrastructure. It could be a lack of adequate compliance or within our applications themselves. So how do we leverage security practices and tools and build trust? We do it like we do everything else within our industry. Instead of trying to say, okay, let's do security, let's do it in little pieces, break it off into achievable chunks. Continuous security is about applying these practices and tools across the entire life cycle. You may have seen a life cycle that's kind of the figure 8. I like just drawing a cycle. So at every phase, from discovery and planning to development, all the way through deploying into production and monitoring what's happening, we can take steps to improve and reduce our risks. We need to level up the skills of everybody within our organization to apply these security principles. We can't, the whole premises of DevOps is that we get more understanding. Well, it's time to apply that to security as well. Today, I'm gonna talk about a lot of different things. I can't cover everything, so this is kind of where I'm gonna approach it from. I'm gonna first set a common context, because so often we use words and they have slightly different meanings, and we assume that everyone understands what we're talking about, so I'm gonna just set the context. Then, I'm gonna build the foundations. This isn't gonna be every single security aspect that you can apply into your development lifecycle, but I want to help provide some context of where you can start. And then I'll talk a little bit more about advancing principles, steps you can take if you got all the basics down. There's a lot more though. I am barely scratching the surface with what I'm gonna talk about today. I mean, this is why there's whole textbooks on security. So, but a core belief I have is that we need to create continuous learning environments. And so part of that is continuously learning and applying the knowledge that we can learn about security. So let's talk about the core goals of security. This is known as the CI triad: confidentiality, integrity, and availability. So confidentiality is the fact that the people who should have access to data, the policies, the rules we have, those are the only people who have access. Then we have integrity. So that means the data is durable, but also that we're not allowing anybody to just change the data. Only the people who have access and should be changing it have that access. And the piece that people often forget about is availability. It's not secure if it's locked up in a vault and people can't have access to it. You have to have access when you need that access to do the changes or see the data that you need to see. Security issues come in two flavors. When we talk about security issues, we're not just talking about, oh, here's this problem. The first one is we have security bugs. A bug is something that I implemented it and there's a problem in my implementation that leads to a failure with the system. So for example, Heartbleed was a security bug. We all recognized what would happen and we went and fixed it. The second one, a security flaw, is kind of harder to find because we've implemented it and it's a failure with how we use it. It might be intentionally implemented that way. And so often the discovery of these are well after other things have been built on top of it. And if you have to change the implementation, often you have to throw away all of the code and start over. That's pretty challenging. One perspective that helps us form our ideas of what we need to think about when we're writing secure code is to think about what are the motivations of the people that are trying to hack me. Often I hear from folks who are like, well, I've got to protect against these insider threats. That's not actually the top concern we should have. The top concern are the people who are getting financial gain. And the other aspect that we have to think about is what kind of data are we generating? So often when I talk to different groups that are asking me for help on building their systems, I ask the simple question, what is the value in your data? So often people are like, what do you mean? So it's even a step beyond just talking about how do I frame and plan what my data looks like inside of my database. Just like, what data are you generating? What value does it have? So much of what we generate and create in today's society, people just assume it's perfectly fine. There's nothing special about it. But there's a reason that if we have all these different services with all this different data and people are able to collect it because we have insecure systems, they can build really bad things that take advantage of people and impact the trust they have in us. Okay, so we've got some context. Let's start building that foundation. When we think about systems, we shouldn't think of, okay, I have a secure system. That's not how it works. We have to think about it in defense, as defense in depth. So let's just choose and pick things in those small pieces and build up a more secure application. We're not trying to get 100% availability, 100% security. That would be too cost prohibitive. So we have to design based on this small steps. Many of us use open source. I mean, show of hands, how many people use open source within their environments, right? One step we can take is take a look at the security of the open source software that we have and use. So often there are vulnerabilities in those dependencies that you don't even know about. Or there's an assumption that somebody else is taking care of the security on this because that's how it's done, right? One great win you can have today, contributing, especially for Hacktoberfest that's coming up in October, is taking a look at some of the software that you use and the dependencies and submit some pull requests on having a security scan of some sort. GitHub actually provides this now as a feature. So if you get these little alerts that say, hey, from the security bot that you have issues with your code, you can totally go ahead and fix those. When we first are designing our applications and we're thinking about how to build and what we're building, a key aspect is creating that psychological safety within our teams to be able to voice problems. How many people feel comfortable that they can actually say something out loud in a team meeting to say, hey, this has this security problem? How many people don't feel comfortable? It's cool. This is a safe space. We can share our feelings. If you're a manager and you see your employee raising their hand, you're not allowed to talk about it outside of here. It's critical to talk about our CIA issues inside of these meetings we're planning and discovering what we should be building. One aspect of this is ensuring that we are able to put security stories into whatever workflow there is, because when we have a security incident, we need to be able to use that same flow, right? So this helps to get things into the flow so that we can handle them. Just yesterday, I heard a little story about someone saying, hey, I keep reporting the security issue and it doesn't get fixed, and everybody gets scared, but then we just put it off for another day. This is a sign that there's a systemic issue that needs to be fixed in the environment to help people have security stories going through and getting fixed. A key part of including security stories is prioritization. If features are always the ones prioritized up ahead of security stories, that means they're never going to get done. So an example of how to frame a story, instead of saying, for example, if I had to have a members only site on a website, instead of just saying, given a registered user, when they log on, they go to an authorized site. Instead, we talk more about what can a user see? What can they do? Where am I logging the information about what they're doing and seeing? And then how do I approach failed logins? If I immediately send them off and assume that it's a hacker if someone fails to log in, that's going to cause problems. Should I do it after 5 failed logins, 10 failed logins? How do I detect whether they're a bot or not? The OWASP Foundation has this open source tool, the Application Security Verification Standard Project, and it has a whole list of helpful hints to how you can shape for your mobile and web applications the security stories that you need to think about. I talked a little bit about what the hackers are doing and their motivations and how we look at different applications. One aspect of figuring out stories is thinking through how to model the threats that we have. And this is the process of which we identify, prioritize, and document potential issues with our systems. We have to think as if we're a hacker and think about, okay, what data can I access? And then look at all the attack surfaces, which are all the entry points, the database connections, all of those pieces where people might have a vector to attack our systems from. Another area to think about is when we're just figuring out what to choose for our architecture, there are trade-offs that we think about. And often the ones that I hear people talking about is the cost or lock-in. And I don't find those very interesting. And the reason is because cost isn't really a good way to measure this when we're choosing between a fully managed system versus someone implementing a lot of this stuff on their own. And part of that is I think we undervalue the people who are doing this. And so just as an example, you can deploy a managed Azure MySQL instance, and it's going to have secure connections, it's going to have encrypted storage, it's going to have all these compliance features, it's going to have encrypted connections between your application and the database, and that is going to provide a certain level of assurance for you and that you can eliminate man-in-the-middle attacks. And so then people look at that and go, oh, that's super costly, but you can do all of this yourself. You can deploy MySQL on a VM instance and secure it if you know how. A lot of the tutorials and walkthroughs that I see, it's always like opening everything up to make it really easy to deploy. And anything that's easy to deploy is generally going to be easy to take advantage of as well. I'm not saying one choice is right and one choice is wrong. If you have the knowledge and the experience in-house, it totally makes sense, potentially, for you to manage this kind of stuff yourself. The key thing is, we hand off, in our cloud native experience, we hand off some of the operational burden, not all of it, to the cloud provider so that they can handle the security from a broader sense. So if I look at the different options that are available, whether it's infrastructure as a service, platform as a service, software as a service, or serverless, if I go up, I am basically saying, the cloud provider, depending on what type of thing it is, I'm going to provide that service to you, the operational side. But there is no solution anywhere that a service could provide to you that is 100% security. You can't provide that yourself, but there are certain areas that no provider can do this for you. Without the context of what data you're generating and the value your company is bringing to your customers, that is on you to know and understand. So you have to be responsible for your data, your classification of who should have access and how, and also to some degree your data points, your data endpoints, no matter what choice you make. A few years ago, I noticed a trend that we're sort of eliminating testers from our teams. And the idea is that developers can do all the testing, and now it's developers can do all the ops, and developers can do all the security. I am not that kind of DevOps. We all have specialization in our skills for a reason, and it's fine. If we talk and share, it's great. But testers are absolutely critical to ensuring and helping you reduce your risk in your environments. One of the ways that you, like each and every one of us, can implement testing in our environments is to add linting to our CI/CD pipelines. Now, a lot of people will tell me, Jennifer, linting is just how the code looks. It's just style. Well, guess what? Style matters when you're trying to figure out what is going on with your code. And you know what, 6 months from here, you will appreciate you for doing this, because it allows you to have some consistency in your code style across the team and with yourself as you learn new patterns. It also helps to provide you information about security issues in your code, like flaws in the code itself. There's this really interesting iOS case where there was 2 go-to fails, and this allowed for, it eliminated the signature verification validation from the code. So if they'd had linting as their first step before committing the code, it would have caught this and this wouldn't have gone out. So yay, let's all lint. But you might tell me, linting is painful. I get all of this error messages and I'm going to ignore it anyway. Well, there's reasons we have coding standards, and you can actually encode into your configuration for the linting what errors you want to ignore. So you adopt a coding standard. Create configurations for your linters so that you can only lint what you want and have it report errors about what you care about. Collaboration is critical as well. And often when I hear about people doing pairing, it's only from a perspective of the 2 developers go and pair. Well, wouldn't it be nice if you had someone with a security mindset who could pair with someone writing code to ask those critical, hey, what about CIA, as they're writing the code? Pairing is helpful across the team and doesn't just rely on just the people who know how to code. Always have someone, even if you don't have an official security person or an ops person with a security background, someone take on the perspective of, I'm not coding, I'm gonna think like that malicious attacker while you're writing the code. Tag the commits as well, anytime it's specific around areas of the CIA pieces, so that you know when you're looking back and trying to figure out where are the areas where we thought about this, you can find them easier. So security events are going to happen. How do you handle them? You need to plan and use what resources are available across your platforms. Every platform is going to have a variety of different tools available to you, and the key is being able to identify, assess, and remediate those issues. My coworker, Jason Hand, actually has this great minimum viable response plan presentation. And it's super critical to have this resource before you need it. In the event that you're having an issue, You don't want to be trying to do fire drill, like what do we do now? And an incident response plan does not mean the subject matter expert is the one trying to drive everything. So often I go into environments and I love and I enjoy these opportunities, but when I see and hear folks running around and the person who's on call is also trying to manage the incident, that's not going to be helpful. They're also trying to manage, they're doing context planning, context switching of whether they're responding to an issue, communicating out what the problem is. Come up with this response early. There is a key difference with security incidents as well. There's two actually. First, often when we discover that an event has happened, it's well after the event started. How long have you been compromised for? So your response might be totally different in that case. It also might be that no impact has happened yet. A lot of times people in authority places will be like, how important could this be if there's no impact? And so you need to have that leverage to say, okay, this is a security event. We have to remediate this as soon as possible so that we don't impact the trust of our customers. If you were on an ops team when Heartbleed was released, you know what I'm talking about, how everyone just was like, we got to get this upgraded as soon as possible. Leverage your platform services. I've mentioned this before, and understand what the limitations of your platform have. One of the things I like to share is the Azure Security Center. I talk to so many people and they don't know that there's this like free part of their service. And every service is going to have some context that will provide you visibility into your infrastructure. I like the Azure one because I can see the visibility of what problems there are. The red ones are bad, super bad, and I can tackle them and eliminate those problems because it has a list of what steps I need to take to fix. Okay, so from discovery to deployment, we have some steps that we can take. If we work towards upgrading everyone's skills, we can level everyone up to be more security conscious. Once you have some of these basic skills going on in your environments, you can start applying more advanced principles, like bug bounty programs. I don't advise this as being like, oh, I'm building an application, let me go spend some money on a bug bounty program. But bug bounty programs are where you pay the community to try and hack into a specific set of environment conditions that you set around your program. Examples of a tool are like HackerOne that will allow you to define how you want to pay people to do this. Another way that individuals can level up their skills in a cooperative manner is capture the flag events. These are where there's a flag, there's security stuff. This will also make you absolutely paranoid about everything in your environment, as you see how easy it is to hack into systems. But I would also, if you are a non-binary person or a woman, the CTF distributed team, the CTF circle, is a great place to do some collaboration and in a safe space to learn about capture the flag events. Red team exercises are really useful after you have an incident response program in place. This is where you have attackers and defenders, and sometimes the defenders don't know that this red team exercise is happening. But the idea is to discover system issues in your environment. So what do we do next? Or what do you do next? Well, identify where you are at. I've given like a whole broad spectrum of different aspects of security that you can apply in your environment. Assess what practices are useful to you right now. Encourage everyone to learn security skills. We're not saying that everyone has to be a security engineer, because again, DevOps. But let's have everyone have some basic understanding. We can't just say, like, throw the security over the wall, because that's not going to help us build trust in our teams, and it's not going to help us build trust with our customers. Incorporate the feedback you get And update your threat models as things go on, as you build new data, as you build new features. You're going to have new vulnerabilities that you need to talk about and discuss. Let's stop making security be in conflict with features. We are trying to build a product that lasts, and we want people to trust us, and we want to value the trust that they give us. Thank you so much for the time that you've given me to share my feelings about this. You can reach out to me at jennifer@modernoperations.org. You can find me on Twitter @SIGJE. If any of this is interesting to you, please speak up at the Open Spaces URL. That's a great place for us to go further into these conversations. I want to have a coffee ops session tomorrow morning, September 27th at 8:30. So if you're an early morning person and want to do some fun stuff tomorrow, we'll do that. And ongoing Abby, who is here today, is going to be running a coffee ops here in London. Thank you again. It's been a pleasure.